Okay, so I wanted to show you in Crunchit how to do exercise 426. In order to bring in the data, because it's referring to exercise 328 and table 3.3, we're going to go to File, down to Load from the Practice of Statistics. This is how we load in our data from the textbook. We are going to, since it's referring to exercise 322, I'm going to pick chapter 3, and I'm going to go down to table 3. And that's how we get the table 3.3. Okay? Now in this problem, we are just going to use the actual volume as well as the 2D visual reconstruction. We're not using the 3D, but it did bring that in for us. Okay, so to do the scatter plot and to get the regression line, we're going to go into statistics. You know, previously we did do graphic scatter plot. That will just give you the scatter plot. But if we go into statistics and go down to regression, this will give us our equation of our line as well as our graph. So we're going to go over to regression, statistics, regression, simple linear. Okay, for our dependent variable, because that's our response variable, we're going to pick actual. For our independent variable, because that's our explanatory variable, we're going to pick the 2D. Okay, now we have a couple options here on our display. We can pick numeric results, which will give us the equation of the line, which we're going to want, and we can also pick fitted plot. Excuse me. If I go ahead and pick fitted plot, calculate, what that's going to give me is my scatter plot with my line, my best fit line. This is the line, sometimes called the best fit, the regression line, and it's minimizing the squared distance to each one of these points. Okay, so this is our predicted value where the points are the actual values. Okay, so that's one way to do our scatter plot with the regression line. Now if we need which you're going to need the equation of the line, I just go back into statistics, regression, and I'm going to go to my numeric results. And again, hit calculate. And this right up top here will be your equation of the line that you're going to want. Okay? And we're going to use this equation. This 0.2649 is your slope, and the 0.3367 is your intercept. So you would use this equation to determine the predicted actual volume of an oyster with a 2D reconstruction of 35,000 pixels. Then we plug in for the 2D right here. You substitute in the 35. That would be in part B, okay? And you take 35 times the 0.2649 plus 0.3367, and that will give you the predicted value for the actual volume. Okay? To get how accurate the prediction is, that's where you want to find the percent of the variation in actual oyster volume that can be explained by the 2D reconstruction. Remember, the remaining variation is unexplained. So the way we do that is with R squared, if you saw the notes. So in Crunchit here, we're just going to go down to correlation. I'm going to do actual in 2D, hit calculate. That's my correlation coefficient, 0.9198, shows a very, very strong linear relationship, as we saw in the scatter plot. And then to get the it's actually called the coefficient of determination. We take the 0.9198 and square it. You can do that on your calculator to give you 84.6% of the variation in actual oyster volume is explained by the 2D visual reconstruction. So the remaining almost 16% is unexplained. Okay, now doing that on the 8384 calculator, I can do another video if you want, and that will give you both the R and the R squared. But from Crunchit, we get the R and then we manually square it. Oops. Okay, if you have any questions, then let me know, okay?